Next topic is recursion. Recursion is the process in which a function calls itself to work on a smaller problem. A function which calls itself is called a recursive function, and such function calls are called recursive calls. Recursion involves several number of recursive calls. Hence, it is important to have a termination condition of recursion. Recursion cannot be applied to all the problems, and it is useful for tasks which can be defined in terms of similar subtasks. Generally, iterative solutions like using loops is efficient than recursions since function calls is always an overhead. A recursive function performs the task by dividing it into subtasks, and there is a termination condition defined in the function which is satisfied by some specific subtask. After this condition, the recursion stops and the result is returned from the function. So the format of the call is if it tests for the termination condition, then if it is true, then returns value, else again continue with the recursive call. Let's see an example for recursion. So this is the program to generate the Fibonacci series using recursion. And as discussed in the other video, Fibonacci series is a series of numbers where first two numbers are 0 and 1, and next number is the sum of previous two numbers. So this function Fibonacci accepts I as parameter, which is of data type int, and the function returns value of type integer. So based on the value of I, the termination conditions given are if I equal to 0, then return 0. If I equal to 1, then return 1. Otherwise, return Fibonacci of I minus 1 plus Fibonacci of I minus 2. So in this case, Fibonacci of next number, so number I is nothing but the sum of Fibonacci of I minus 1 and I minus 2. Similarly, Fibonacci of I minus 2 makes recursively calls Fibonacci function with the value of I decreased by 2. In the main function, it accepts the user input for value n, and it calls the Fibonacci function for values ranging from 0 to n. Next, we will see how function calls are managed using stack. Stack is a data structure wherein the last item entered in the stack is the first one to get out of it. So it is a last in first out data structure. So the process of adding elements to the stack is called push, and the process of retrieving elements from stack is called pop of operation. So when each recursive call is made, the copy of the method and variables are stored in the memory. Once the data is returned by the method, the copy is removed from the memory. For every recursive call, a separate stack is maintained, and when the function call is completed, the stack gets destroyed. Next, we will see an example for a function call and how the stack is used during the function call. So at the beginning, the stack is empty. So in this function, the main function, we are having three variables A, B, C. A and B are initialized with the values 5 and 2. And C is assigned with the value returned from the calc function which accept two variables A and B as parameter. Inside the calc function, it finds the sum. which is sum equal to I plus j, and it returns sum. And the value returned by the calc is assigned to the variable c. So from main function, when at statement 4 it makes a calls to the calc function. So we'll see how stack is used in this case. So in the beginning the stack is empty. When the call to calc is met at statement 4, the existing variables a and b are pushed to the stack. So they are added to the stack. And the address of the next statement, that is printf, is also added to the stack. So let's assume address is xxyy. So then the control is transferred to the calc function. Inside the calc function, the calculation of the variables, addition of the variables happened, and the values assigned to the variable sum. So now we have to return the value to the calling function. So the value of sum is also pushed to the stack. On returning to the main function, this value is popped, is removed from the stack, and it knows the address, which is the address location of the next instruction is, and it display the result in the screen. After that, instructions are over and the stack become empty. Similarly, during recursive call, that is, function makes several calls to complete the task, and the values get pushed and popped from the stack as part of each call. So that's how stack is maintained during the function call.